Good morning, afternoon, evening, from wherever you're watching. You're welcome back once again to the Mickey Mouse Class, a channel solely dedicated to demystifying mathematics, making complex things easy. Alright, in our last class, or in our last lesson series, we examined indices. If you have not watched, check out the series on indices. Today, we'll be looking at the logarithms. One quick one, if you're here to subscribe, to hit the subscribe button. Tell your friends about the Mickey Mouse Class, a place you want to be. All right, logarithms. Now, logarithms and indices are related. What is the logarithm of a number? Now, the logarithm of a number, let's say n, to a certain base, let's say x, is the power to which this base must be raised to give this number. For example, if I have logarithm of n base x equals a. Now, this is the power to which the base x must be raised to produce n. That is the long and short of logarithm. So logarithm is the power. Another name for logarithm is power. So it's the power to which this base must be raised to produce n. Now we have what we call the laws of logarithm. Just like we have the laws of indices, we have the laws of logarithm. And let's examine them one after the other. The first law, if log xy to the base of a, log of xy, that's x times y, to the base of a, is the same thing as writing the log of x base a plus the log of y base a. So that's the first law of logarithm. If you have log xy to the base of a, is the same thing as writing log of x base a plus log of y base a. The second law, if you have log x over y, that's x divided by y, is the same thing as writing the logarithm of x to the base a minus the logarithm of y base a. The third law, if you have logarithm of x raised to the power of n, logarithm of x raised to the power of n base a, is the same thing as using the power to multiply this log. It's the same thing as saying n times logarithm of x base a. So when you have a scenario like this, use the power to multiply the log. And the fourth law, logarithm of a number, let's say a, to the same base, logarithm of a to base a is equals to 1. If you have, for example, log 10 base 10, it gives you 1. Log 5 base 5 gives us 1. All right, the fifth one, if you have logarithm of x raised to the base a raised to the power of n, that's log x to the base a raised to the power of n, is the same thing as 1 over n log x base a. So when you have log x base a raised to the power of n, is the same thing as 1 over n log x base a. Let's take quick examples on this certain law. These are the basic laws. Example 1, evaluate log 1000 base 10. Evaluate the logarithm of 1000 to base 10. So straight up, we say let log 1000 base 10 be equals to x. And from our definition of logarithm, we said the logarithm of a number, logarithm of 1000, is the power to a certain base, which is 10 here, is the power to which the base must be raised to give us this. So what we are looking for is the power to which 10 must be raised to give us 1000. That's the logarithm of 1000. Now, this becomes 10 raised to the power of x equals to 1000. So what must I raise x to, 10 to rather, to give me 1000? This 1000 can be split into 10 raised to the power of 3. Because 10 raised to the power of 3, 10 times 10 times 10 will give us 1000. Now the bases are equal. We cancel out, so our x will be equals to 3. So the log of the logarithm of 1000 is 3, because 3 is the power to which the base 10 must be raised to give us 1000. Alright, let's take example 2. You can have something like this: evaluate or simplify logarithm of half base 4. That's logarithm of 1 over 2 base 4. So the same thing, we say let the log of half base 4 be equals to x. Now, from there, 4 raised to the power of x, 4 raised to the power of x is equals to 1 over 2. 4 raised to the power of x equals to 1 over 2. Now, let's break this, simplify this down. 4 is the same thing as 2 raised to the power of 2. So this is 2 raised to the power of 2. We have our x times x, that's 2x. And from our indices, when you have this, 1 over 2 can be rewritten in the reciprocal form to be 2 raised to the power of negative 1. 2 raised to the power of negative 1. Now, the two of them have the same base, so we can cancel out. 2 we cancel out 2, so we have 2x is equals to minus or negative 1. From here, divide both sides by 2 to get your x. So x will be equals to negative 1 over 2 when you divide both sides by 2. So the logarithm of 1 over 2 half base 4 is negative 1 over 2. Alright, let's take another example. Simplify log 9 over 4 base 2 over 3. The logarithm of 9 over 4 base 2 over 3. Alright, the same thing, we say let logarithm of 9 over 4 base 2 over 3 be equals to x. Now, this becomes 2 over 3 raised to the power of x is equals to 9 over 4. 2 over 3 raised to the power of x equals to 9 over 4. Now, let's break this 9 over 4. Let's rewrite it so that it will look like what we have here, 2 over 3. How do we do that? We know that our 9 is the same thing as writing 3 raised to the power of 2. And our 4 is the same thing as writing 2 raised to the power of 2. Because 3 raised to the power of 2 is 9. 2 raised to the power of 2 is 4. 2 times 2. So it's equals to 2 over 3 raised to the power of x. So this becomes 2 over 3 raised to the power of x is equals to 3 over 2 raised to the power of 2. Now we can take the reciprocal of this so that it can be equal to this 2 over 3. Now the reciprocal of 3 over 2, what needs to change is this power. It becomes negative. So this becomes 2 over 3 raised to the power of x equals to 2 over 3 raised to the power of negative 2. 2 over 3 raised to the power of negative 2. Take the reciprocal of this. That's what you get. Now, these two are now the same. So they can cancel out each other. So our x equals to negative 2. Alright, let's take another example. You can have evaluate logarithm of 1 over 32 base 1 over 2. Logarithm of 1 over 32 base 1 over 2. What do we do? Let's split this 1 over 32 into its simplest form. So this is logarithm of this 1 over 32 is the same thing as 1 over 2 raised to the power of 5. 1 over 2, because 2 raised to the power of 5 will give me 32. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. Now it's the same thing as rewriting it as log 1 over 2 raised to the power of 5. Why? Because 1 raised to the power of 5 is still 1, so it doesn't change anything. Then 2 raised to the power of 5 is what we have here. Now, remember the law there. We have this power can be brought here. So which is equals to log 5 times log 1 over 2 base 1 over 2. The power here can be brought here. This is the same thing as 5 multiplying the log. And now the base and the logarithm of the number to which you are finding the logarithm are the same. So the logarithm of a number to the same base is 1. So this and this will go. So this is the same thing as 5 times 1, which is equals to 5. If I have log a to the base a is the same thing as 1. I think that was the fourth law that was given. So log 1 over 2 base 1 over 2 is 1. So the answer of this logarithm of 1 over 32 base 1 over 2 is 5. The next question, let's take find x if logarithm of x base 9 equals to 1.5. It says find x if the logarithm of x to the base 9 is equals to 1.5. Now, first of all, so our solution, log x base 9 equals to 1.5. Now, this is the same thing as writing 9, the base raised to this, raised to the power of 1.5 equals to x. The logarithm of this number is the power to which this the base, which is 9, must be raised to give us x. That is why it is like this. 9 raised to the power of 1.5 equals to x. 1.5 is a decimal number. We can rewrite it in fraction form. And when you are rewriting it, that's 9 raised to the power of 15 over 10. 1.5, bring up the decimal point here. That's 15 over 10. Now, 15 over 10 can be further split down into its simplest form. 5 can divide. 5 in 15 is 3. 5 in 10 is 2. So you have 9 raised to the power of 3 over 2 is equals to x. Remember from your fractional index law, from indices, this is the same thing as taking, so x is equals to taking the square root of 9, raising it to the power of 3. 9 raised to the power of 3 over 2 is the same thing as taking the square root of 9, raising it to this power. So the square root of 9 is which number will I multiply twice to give me 9, which is 3. So this is 3 raised to the power of 3. So 3 raised to the power of 3 is 3 times 3 times 3, which is 27. So 27 is the value of x. So 9 raised to the power of 1.5 will give us 27. Okay, let's look at this final example for today. It says find the logarithm of 24 base 2 given that log 6 base 2 is equals to 2.58496. Now the first thing, we already have what to work with. This is log 6. We have been given the value. Now what we need to do is to split this 24 to be like this 6. Now how do we do that? So log 2, 24 base 2 is the same thing as writing logarithm of 6 times 4, because 4 times 6 base 2. 4 times 6 will give me 24. So it's the same thing as, since I already have my 6, logarithm of 6 base 2 to be this, so I can work with that. Now, from the law we have, is the same thing as, this is the same thing as splitting it from the first law of logarithm. This is the same thing as splitting it to be logarithm of 6 base 2 plus logarithm of 4 base 2 from the first law of logarithm. When you have two identities multiplying, or two numbers multiplying, it's the same thing as adding them to the same base. It's the same thing as adding them. Now log 6 we already have, it is 2.5, so this is 2.58496. Now let's simplify this. This becomes plus, this is log 2. 4 can be written as 2 raised to the power of 2. 2 raised to the power of 2. And from our log of, I think the third law that was given, when you have a scenario like this, a power is the same thing as putting the power here. So this is plus 2 log 2 base 2. That's 2 times log 2 base 2 is equals to 2.58496. And when you have the logarithm of a number to the same base, it's the same thing as 1. I think the fourth law. So this becomes 2.58496 plus 2 times 1, and 2 times 1 is 2. So this is 2.58496 plus 2, which is equals to 4.58496. So the value of log 24 base 2 is 4.58496. I hope you have enjoyed today's lesson. If you have any question, you can put it in the comment section. Let me know. If you have not yet subscribed to the channel, please do well to subscribe, like our videos, share our videos, tell your friends about the Mickey Mouse class. Until we meet again, in the next class we'll be examining logarithmic equations, how to solve logarithmic equations. But this is the basis or the foundation of logarithm. I hope you have enjoyed today's class. Till we meet again, stay blessed. Shalom.